In Chapter 9, you'll learn about the floating point unit on the TM4C 123G H6PM. All of TI's Cortex-M4 devices are equipped with a floating point unit, though for code compatibility reasons, it's switched off at reset. You'll learn about the basics of floating point numbers and how Tiva C-series devices implement them. Floating point is a way to represent real numbers on computers. There are several IEEE floating point formats: half precision at 16 bits, single precision at 32 bits, double precision at 64 bits, and quadruple at 128 bits. IEEE 754 is single precision and the format used on the Tiva C-series devices. IEEE 754 defines a single precision floating point representation for numbers. In the top figure, note the sign bit on the left, followed by 8 bits of exponent, and finally 23 bits of fraction. In the other two figures, you'll see how the numeric representation in memory can be converted into a decimal number. The floating point unit on the Tiva C-series device provides floating point computation functionality that is fully compliant with the IEEE 754 standard. The Tiva C-series floating point unit supports single precision adds, subtractions, multiplies, divides, single cycle multiply and accumulate, or MAC, and square roots. The figure at the bottom shows the additional instructions added to the base Cortex-M4 set by the floating point unit. There are three different modes for operation for the floating point unit: full compliance, flush to zero, and default non. Full compliance mode is where the floating point unit processes all operations according to the IEEE 754 standard in hardware. There's no additional support code required. In flush to zero mode, a very small result, as described in the IEEE 754 standard, is replaced with a zero. In most cases, that's probably what you want to do. Non stands for not a number. In default non mode, the result of any arithmetic data processing operation that involves an input that's not a number or generates a result that's not a number will return the default non. If you perform a divide by zero, that's a non or not a number. The floating point unit has 16 64-bit double word registers D0 through D15 and 32 32-bit single word registers S0 through S31. The floating point unit is disabled from reset. You must enable it with a TivaWare API function call before you can use any floating point instructions. The processor must be in privileged mode to read and write from the control register, and the API performs this function. The floating point unit sets the accumulative exception status flag in the exception register as required for each instruction. The floating point unit does not support any user type traps that you might write. The processor can reduce the exception latency by using a technique called lazy stacking, which is supported by a TivaWare API. Lazy stacking means that the processor reserves space on the stack for the state, but it doesn't save that state information to the stack unless it's necessary. ARM has developed the Cortex Microcontroller Software Interface Standard, or SEMSIS. Included in SEMSIS is a DSP library that you can use to create your own DSP-type functions. Benchmarking the M4 versus the M3, even in fixed point mode, the M4 is about twice as fast as the M3. With the floating point unit, floating point code runs about 10 times faster on the M4 than with the M3. In Lab 9, you'll experiment with using floating point code to generate a sine wave. You'll profile the code to determine how many CPU cycles it requires to execute.